Hello and welcome to the Module 1 second video, Introduction to Raspbian. In the first video we introduced the hardware and now we're going to talk about the software, the operating system inside the Raspberry. Linux is a Unix-like computer operating system assembled under the model of free and open source software development and distribution. There are many Linux versions like Ubuntu, Red Hat, Fedora, and many others. The Raspberry Pi can work with several Linux-based operating systems, including Ubuntu Mate and Windows IoT. The most used and the one we will be using is Raspbian. In this video, we will show you the basics of Raspbian. When the Raspberry boots up, a desktop environment is loaded by default. This is the GUI, Graphical User Interface. We can work with Windows and files as we do in Windows OS, Mac OS, or other Linux-based operating systems. As in the OS X or Windows, there are typically two main ways to execute applications in Linux: through the Graphical User Interface, GUI, and through the command line, known in Linux as the console or the terminal. Here we are. For example, we can run the text editor from the taskbar, going to Accessories, Text Editor. Okay. We can type whatever, we can save the file. For example, you have it here, or we can run it from the terminal, writing leafpad, and here we have our terminal again. It is very important to be able to use a terminal because there are some tasks that can only be performed in the terminal and some other are easy to perform in the terminal. For example, some basic commands that you probably know are ls for listing files, cd to change directory, mv to move files, rm to delete or remove files, rmd to delete directories. To execute files, sometimes it is important to specify the path. For example, if we go, we can list the directories that we have in our home directory. We can move to Python games, for example, to play a little bit. We can check what do we have here. Okay, and we see that we have a file called launcher.sh that is an executable file. We can try to launch it, to execute it, but then we found that the command is not found. But if we put /launcher, then we can find the file and execute it. Okay, just as you know, you have some games inside the Raspberry, so you can play, for example, Flippy. It's a game like Rubbersy. Okay, and well, we can start playing a little bit with the game. Okay, we close it. Some commands need a special permission and must be executed with root privileges. In that case, the command sudo must be used, followed by the root password. For example, if we want to write stuff in a specific directory, in a system directory, we cannot use leafpad like this, because it will not allow us to write in that directory, but we can write like sudo leafpad, for example, and then we can write in system directories. Okay. So the next thing is a Linux file system. The way Linux deals with drives, files, folders, and devices is somewhat different to other operating systems. Instead of having multiple drives labeled with a letter, everything appears as a branch beneath what is known as the root file system. If we clean it a little bit, okay, we can move to the home directory and display what we have. If we want more information, we can put like this. If you go into the PI and type ls, as we did, you'll see various directories displayed. Some of these are areas of the SD card for storing files, while others are virtual directories for accessing different portions of the operating system or hardware. For example, we can have the bin directory for operating system related binary files, the dev directory where all the devices connected to the system can be accessed from here, like USB drive, for example. etc stores miscellaneous configuration files. We have here our home directory where our files are stored. Okay, we have the PI. We have the lib directory, very important. This is a storage space for libraries, which are shared bits of code required by numerous different applications. We will work with many libraries in this course. And for example, the user, this directory provides storage for user accessible programs, and this for TMP, for temporary files. In order to execute files, they have to be executable, as we have seen previously. Each file or directory has three basic permission types: read, write, and execute. If we go back to our home directory, we press ls. Okay. We have here the permissions for the file. When the command line, the permissions are edited by using the command chmod. You can assign the permissions explicitly or by using a binary reference as described below. For example, we can create a file in the text editor. Whatever. We save it in the desktop as test2. So we have it, in the desktop. So we have here test2. If we try to run the file, it says permission denied. Okay. So if we change permissions, we write chmod a plus x. We want execution permissions for the file test2, and we display again. Now we see test2 is in green. That means that it's executable. We can see that because of the X here, we have X execution permissions. We have three groups of permissions. Okay, we have the user, the group, and everyone permission. Okay, so now we could type test2, for example. We run it, and it says that this is not executable, command not found, but the file was executed. Okay, so with chmod you can add permissions. For example, you can add permission for execution or remove permission, so you can write whatever you want. A plus for adding, you can put rwx, you give all permissions, and with this you remove all permissions to the file that you write here, or just single one. If you want to remove execution permissions, use this, and you use R for read, W for write, and X for execute. Okay, so let's move to processes. A process is an instance of a program running in a computer. A process can initiate a subprocess, which is called a child process. And we can have several processes running in our system. For example, one process to gather data, one process to use the data, and one process to send the data to the cloud. To see the processes running in our system, we use the command ps. Okay, we can remove this. So right now we have two processes, bash and ps, running in our system. These are ps provides information about our currently running processes. I mean our the processes in our profile in our session. If you want to see all running processes, including the system ones, you can use also the top command. You have here all running processes and how they are changing in real time. Press Q to exit. Okay, let's move to how to install software in the Raspberry Pi. Installing new software onto this Raspberry Pi is quite simple, although it is not the same as in Windows systems. It includes a tool called apt, which is a powerful package manager. Okay, so apt is our package manager. You can see you have different instructions regarding apt. Packages are what Linux calls a piece of software, or a collection of different pieces of software designed to work together. Although apt is designed to be operated from the command line, it is very user-friendly and easy to learn. Nevertheless, there are GUIs for apt, such as the popular Synaptic Package Manager. Okay. Synaptic, you can install it in the Raspberry Pi, but they often struggle to run on the Pi due to the lack of memory. As a result, we recommend using apt from the terminal. So, we can clear a little bit. The first step to install a new piece of software is to make sure the apt cache is as fresh as possible by running an update. So we can write sudo apt apt get update. Please make sure that you are connected to the internet, and this will update the information of the software available of your software installed in the Raspberry Pi. This may take a while, so you have to wait a little bit. Okay, so we're back. We're done. Okay, we have the system updated. Second thing is to find the name of the package that we want to install, either in the web or internet, or using apt cache search. For example, apt cache search, we can find, I don't know, pcool, for example. That's a library, and we find you have all these different libraries. The pcool, for example, for Python 3 and for Python. Okay. You can use, I know, if you want to check for game, for example. Let's see. Well, you have a lot of stuff. Okay, for game. Okay. For pcool, you have those 5 libraries. Then you like sudo apt get install to install the package. So we want to install, for example, this one. Okay, sorry. We're at the whole name, Python PyCurl. We get install. And that's it. Okay. If a package depends on other packages, apt will automatically find them and prepare them for installation. Afterwards, to update packages, use sudo apt-get upgrade. But that takes really long, so we will not do it right now. Okay, so summary: you sudo apt-get update to update the system, then you search for the package. If you already know the name, you don't have to do that. Then you install, for example, you install this library Thrust, and then you could upgrade the whole system. Okay, next thing is how to connect remotely to the Raspberry. This is one of the most useful things in this lesson. So, because in order to use the Raspberry Pi, you need a screen, a keyboard, and a mouse. But since we are using the Pi for embedded applications, these are not always available because you could have the Raspberry in a remote location. For that purpose, we can have the Pi running somewhere and we can connect to it through a remote connection. We'll see two options, SSH and VNC. Using SSH is very simple, but sometimes we have to enable it first. Let's see how to do it. So first, well, you can clear this a little bit, sorry. And then we run sudo raspi config. Okay. We go to advanced options and we have here SSH. Okay, and we can enable. I have already enabled, so but you click on yes. Okay. So now SSH, now I enable it, and this SSH server is enabled. Okay. So I finish. And it's already enabled. Now I want to connect to the Raspberry, but I need to know the IP address, so I can write ifconfig. Okay, and I get a lot of information here. Depending on your connection, if you're connected through Internet or through a wireless LAN, I'm connected through a wireless LAN, so I have my address here, 192.168.2.14. So that's the address that I have to memorize. I open a terminal. In Windows, you can use any software that allows you to make SSH connections, and then I write SSH. The user, in my case, is Pi 168.2.14, and then I write the password. Okay, and I'm already on the Raspberry. I can type ls. If I go to the desktop, I can see the files that I have just created before. Okay, I tap exit to log out. Okay, the second option is VNC. This is the one that I'm using to record this video. VNC is a graphical desktop sharing system that allows you to remotely control the desktop interface of one computer from another computer or mobile device. It transmits the keyboard and mouse or touch events from the controller and receives updates to the screen over the network from the remote host. It is exactly the same as if you were using a keyboard and a mouse on your PC. You see that it moves a little bit slower. That's because I'm using VNC. VNC server is here. VNC server is included by default on the last version of the Raspberry Pi, but you will need to enable it yourself. VNC server will then start automatically whenever your Raspberry Pi is powered on. You can enable VNC server graphically or via the command line. Okay, if we go to the menu, preferences, and then Raspberry Pi configuration, in interfaces, just check that VNC is enabled. Here we have the same as we saw previously. SSH is enabled. If you want to enable other communication like SPI or I2C or OneWire, you could do it also here. Okay, so once our server is running, we can check the IP address here. Okay, by just clicking on the icon, we get the IP address. Okay, so what do we have to do now is go back to our computer and go to, just look for VNC, real VNC, and download the client for your operating system. Once your client is installed, you connect as I am doing here. Okay, just here the dock. Okay, so it's another window in my desktop, and very convenient, very useful to use it. So to conclude this lesson, we have introduced Raspbian, the operating system of the Raspberry Pi. It is very important that you feel comfortable with it before you move on this course. Very important. We have reviewed also how to use the terminal, the file system, how to execute files, processes, and how to install software and packages using apt. Finally, we have seen how to remotely connect to the Raspberry using SSH and VNC. Okay, so thank you for watching and see you in the next video.